Now let me introduce the DC524-001 step-down converter in detail. This DC-DC synchronous step-down power module uses a professional synchronous buck design with high conversion efficiency. It supports a wide input voltage range of DC 11 to 70 volts, and the output voltage can be adjusted flexibly from 3.3 to 24 volts. The output voltage must be at least 2V lower than the input voltage. The converter features real-time display of input and output voltage for clear and intuitive monitoring. The screen will automatically turn off after 3 minutes of inactivity to save power. This module has a rated power of 336 W. At 12 volts output, it can deliver a maximum peak current of 28 A, fully meeting the demands of wide voltage input and high current output in various applications. First, let's look at the appearance of the step-down converter. The housing is made of aluminum alloy. On this side are the input and output terminals for positive and negative poles. Positive input, negative output, and positive output. On this side are the settings. There is a setting button for voltage display and voltage calibration. This is the relay knob, used to adjust the output voltage. Turning clockwise decreases the voltage, and counterclockwise increases the voltage. The adjustment range is 3.3 volts to 24 volts. This is the LED screen, which displays the input and output voltage values. Finally, this is the HY 2.0 connector. It has 2 pins. Shorting them enables the module to power on and work normally. We usually use a jumper cap to short them. If you need an external switch, you can connect an external short switch via the HY 2.0 cable to control the module. When the HY 2.0 connector is not shorted, the module is in zero power consumption mode. When shorted, the module uses a very small amount of power. Therefore, when the converter is used with a battery, you can disconnect the battery or open the HY 2.0 connector if you do not need power for a long time. If you purchase this LVP30V battery adapter, it comes with a detailed instruction manual and corresponding tutorial video. You can scan the QR code on the manual to watch the video. Next, I will explain the specific usage method. I will take stepping down a DeWALT 20-volt battery to 12 volts for 12 volts vehicles as an example. Step 1. Connect the power cables. Connect the red cable with the fuse box to the positive output terminal of the adapter and the positive input terminal of the voltage reducer. Use another cable of similar size to connect the negative output terminal of the adapter and the negative input terminal of the voltage reducer. Then insert the fuse into the fuse box. Check if the jumper cap is inserted into the HY 2.0 port of the voltage reducer. If not, please insert it. Step 2. Power on. Check and set the voltage. After completing the above operations, insert the adapter into the battery. The default high threshold of low voltage protection for this adapter is 16.5 volts, and the low threshold is 16 volts, so you don't need to adjust these values. Press the on button on the adapter, and the adapter will start outputting voltage. At this time, check the output voltage value of the voltage reducer and adjust it to the required 12 volts. Specific adjustment steps. First, make sure the screen displays the output voltage. Short press the key button repeatedly until the screen flashes alternately between OP and the output voltage value. Then hold down the key button until only the output voltage value is displayed. Then turn the relay knob to adjust the output value. Clockwise, to decrease the voltage. Counterclockwise, to increase the voltage. After adjusting to the required 12 volts, Turn off the module. Step 3. Connect the load. With the module turned off, connect the positive and negative poles of the original vehicle input to the positive and negative poles of the voltage reducer output respectively. Note: do not reverse the connection. Reversed connection will burn out the load. After these 3 steps are correctly connected, you can use it normally. If you want the screen of the voltage reducer to display the input voltage for checking the battery level, press the key button repeatedly until the screen flashes between in and the input voltage value. Then hold down the key button until only the input voltage value is displayed. If you find that the actual output voltage does not match the value displayed on the screen when using a multimeter, we also provide a calibration function. Calibration method. Press the key button until the screen flashes cal. Then hold down the key button and the screen will flash the output voltage value. At this time, use the positive and negative probes of the multimeter to measure the voltage at the output terminal and check the readings of the multimeter and the voltage reducer. Then turn the potentiometer clockwise or counterclockwise until the multimeter reading matches the module display. After that, hold down the key button to save the settings, and the screen will flash CAO. Press the key button again, and the calibration is complete. In this video, we used a 20-volt DeWALT battery step down to 12 volts. Of course, this voltage reducer supports a wide input voltage range of DC 1170 volts, and the output voltage can be flexibly adjusted between 3.3.24 volts. Therefore, it has a wide range of applications suitable for golf carts, car audio, heavy trucks, LED lights, advertising screens, monitoring systems, motors, solar panels, laboratories, experimental projects, electronic systems, DIY projects, and more. Alright, that's all for today's video. If you have any questions or suggestions about the product, please contact us via the after-sales email in the manual.